I would like to show you how you can find the longest chain or the principal chain of a chemical structure. So we have a line angle structure of just a simple alkane, lots of carbons and hydrogens drawn. And we want to know what is the principal chain, what's the very longest one. A newbie mistake is to just go for the horizontal line. You'll see, oh, that looks like the parent. Everybody's branching off of that. And if we count up the carbons on here, we'll see that we have 7 carbons as you go along. So you might be tempted to say, oh, 7, heptane. That's the longest chain, the principal chain. You got to be careful because you know these can rotate around in space. And so if you're using the horizontal line, as the parent chain, you just look at this molecule a slightly different way. And what does that even mean, a horizontal line? A good way to figure out the principal chain, the longest chain, is to look at the branch points. In this structure, I have 1, 2, 3 branch points. So I can look at each branch point and see if I were to approach that branch point, is one path longer than the other? Does one path have more carbons? So imagine I'm coming from this direction and I would approach this particular branch point. Then I could choose either to go up or I could choose to go off to the side here. And what I see is when I go up, I enter a 3-carbon branch instead of a 2-carbon branch. The 3-carbon branch is longer, so that would be the preferred pathway if I approach that particular branch point. Similarly, this branch point at the bottom, if I were to approach it from the rest of the molecule, I would either go to a methyl or an ethyl group. The ethyl group is obviously the longer group, so I'm going to go here. Now, in this particular structure, I have this middle branch point, and I can see I don't ever want to go this methyl group. That's very short. So, and it's in between the other 2 branch points. So it becomes obvious to me that the longest chain is going to be the one I just highlighted in yellow. And now we can see how many carbons exactly is that. I have 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5, 6, 7, 8, 9, 10 carbons. So 10 carbons in this particular case is my longest chain, which is decane. So the principal chain would be decane for this particular molecule. Here is a slightly more complicated structure. We have branch points here, 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 and here. So we have 4 branch points. We can go to each branch point and see what is the longest chain. For example, this branch point, I have a 2 length and a 2 length. It doesn't matter which one you choose in this case. I'll go ahead and choose this one. When you go to this branch point, it's obvious this is a longer chain than the methyl group. So I will mark off that one. And then finally, for this branch point here, I have the longer chain going this way. And those are the ones that are, at the ends of the molecule. This one is kind of in between other branch points, so we'll have to see which one makes the most sense. So now what I can do is connect up, find a path to get from one yellow part to another and see which one is the longest. So if I start with this branch here, I can go 1, 2, 3, 4, and let's say I go down 5, 6, 7, 8. So that's one possible length. I could also go 1, 2, 3, 4 and go the other way, 5, 6, 7, 8, 9. So that's longer than the first one. But there's yet one other one. I could start here and go around here. And let's see what that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the longest chain. So let's go ahead and highlight that. We'll get rid of the one that we don't need. And we now have the longest chain.